Hello, you hear me? Great. I think after the previous impressive session, we need to debrief a little bit. So I'm going to to talk about less technical things, but more conceptual things, and complain about pains we actually met. So my session is about, you see the title, and actually it's about the pains we met as a startup. Yes, we are the startup, right? So, and of course we are the special startup. Of course we started with really great R&D. Gleb, the first session, he already shared a lot of things about this. We started with already mature, team who created cloud platform in the past. But we are still the startup because we are playing the game, which was not played by anyone because it's a new market, right? We are the special startup, but all the startups special, right? And as a startup, we started with the hypothesis: what is needed by the market? What do we need to deliver, to create, to develop in our platform to reach our customers? What are the customer needs? What are their expectations, how they are going to use our platform? And of course, we started with the number of expectations, like quite obvious ones, right? So we already spoke about our platform. I'm not going to repeat this in details, but what you as a customer or potential customers, what you need. Of course, you expect best of breed GPU stuff, computing stuff, right? So the latest version of GPU cluster, InfiniBand, support of NVLink. So a lot of technical stuff was discussed today, right? Of course, we have to provide you an access to our platform via API, Terraform, you name it, right? Of course, all of us, we understand one of the most painful challenges in the industry, it is reliability, right? So unfortunately, GPU clouds are not reliable 100%. Nothing is reliable 100%, right? So, and we started with the expectation that the market wishes at least like a medium level of reliability, and our goal is to raise the bar of our reliability, and we invest quite a lot of things into that. At the same time, we decided to be a little bit special because it's not typical for many of our friends and competitors. So we decided to prove that our platform fits to the demands of the market and, reliable enough, and we deliver the feature really needed by the customers. We have to dog food. We have to have dog fooding, and actually the next speaker, Boris, he is the leader of the team who is using our platform, who is a member of our AI team, who is checking all our new features and the products before it goes production. Check not just for sake of checking, but training real ML models, checking with real problems this team resolved. So we are much bigger than just infrastructure company. And I'm the head of customer experience. Of course, I worry it's my major pain point, right? To make our customers as happy as possible. That is why we decided it's not enough to be cheap in the market. It's not enough to be able to deliver big clusters. So when I say big, I'm talking about 4K plus, 8K plus, 10K plus. It's more and more common, at least for us. So unfortunately, I'm not talking about 100K plus GPU clusters. We are not so big yet, but we are very, very ambitious. And it's not enough to be cheap. It's not enough to be big. It's not enough to have the best platform. At least we hope our platform is good enough. But it's also important to understand the customers and help the customers to onboard our platform, right? That is why when we are talking about, and the initial, the title of this session is about large-scale training. All our customers, when we start large-scale training or inference projects, have dedicated solution architects, different flavors of solution architects. We have pre-sales, we have specialists, ML specialists, cloud specialists. We have dedicated solution architects for specific key customers. So these are our expectations in the beginning. Nothing tricky, right? So everything is obvious. So we expected obvious things. So simple, right? Actually, not really, because we made the number of expectations and we failed with that expectations and we learned some lessons and we're still learning, developing our platform. And it's somehow broken. Anyway, so expectations. The first expectation was model builders want to manage all the aspects of the platform. Their wishes and they have desire to tune all the things they need to tune, and they just need to have the infrastructure and the engine just to execute distributed workloads. And the obvious the obvious solution is Kubernetes, right? So based on this expectation, actually we developed managed Kubernetes cluster, and that's it. What was the reality which met our expectation? Actually, what we found is many, not all, but many of our customers, actually, they don't like to touch lower levels of the infrastructure. They don't like to care about what CUDA drivers, NVIDIA drivers, or operators for Kubernetes we need to install. We just like to do our business, right? To be focused on the value we generate, to be focused on the R&D we create, on the interesting things. And infrastructure stuff is boring. That is why we decided to go with, to create our ML platform with ML workloads in our minds. And we built orchestration engines with all the necessary things inside already. You shouldn't care about installing different operators for network, for GPU, installing drivers. You shouldn't think about how to optimize network connectivity and so on and so on. We prepared this stuff for the customers. And we test them, and we do believe that it would work smoothly. There is another side of the medal. Some of our customers, they say, okay, we don't need GPU infrastructure at all. Probably it would be better to go serverless. Actually, we understand that there is such opportunity. And actually, we are thinking, and we are in progress, probably proposing such solutions as well. But at the same time, our customers, they say, okay, we will try to go serverless, and they complain us. So there are some limitations in serverless solutions. There are some vendor-specific things there. Again, I do believe it's the right approach, but it has to be cooked correctly. Okay, so another expectation is checking every component and isolating failed components before providing a cluster is enough to avoid failures. What we did, we expected. Okay, so we execute the platform, the infrastructure, and we test. We execute tests, let's say FIO tests for storage, we execute tests for computing, we execute some tests, synthetic tests for networking, and so on. So if all the components of solution work fine, so probably we're good. Actually not. Actually not. What we found that all the synthetic tests and burns and benchmarks for specific components are not enough to catch all the possible problems. Not enough. Because when model builders execute the real workloads, we always meet other problems we didn't check. So checking specific components doesn't mean that we checked the whole infrastructure. That is why, and it is like an evolutionary approach, and of course we are not even close to the final line here. We are making more and more complicated end-to-end tests. And actually Gleb today during the first session, he already mentioned that we are making our own hardware. That's why we're serial killers, and we are trying to kill as much as possible components as early as possible. So we are making our own servers, and we are starting testing. And of course, we have different sets of tests, and meaning of end-to-end is different on different stages. But we are trying to kill as much as possible on the factory. And next we move our hardware to the data center, and we start killing this and testing end-to-end tests. We are running Nickel or NCCL, if you wish, tests, MLPerf, GPT-free distributed training, specific storage tests, not just to check storage, but storage is a part of ML workload. We are trying to kill our clusters when we assemble cluster. So some components fail, we reassemble the cluster, recheck, and when we start working with the customers, we execute other sets of tests again and again and again. So end-to-end testing is the necessary thing. Do not trust if someone is saying, okay, I tested this and that, everything is good. No, you always have to test the whole platform. Another expectation, we, as Nebius, we can provide the same level of infrastructure reliability for clusters of all sizes by testing smaller chunks, modules, or Gleb already mentioned pods, just another term that means the same. And the reality is, no. Probably all of you familiar with the concept of known unknowns and unknown unknowns, right? Just let me remind you. So known unknowns are the problems you know they exist or potentially can happen, but we don't know when. For example, disk failure. 100% disk will fail. We just don't know which specific disk and when, right? Known unknowns. And when we play the game of scaling, we have a lot of unknown problems. We have a lot of problems we have no clue, and when they happen, and why they happen, and so on and so on and so on, right? So, and unfortunately, on the big scale, you're not able to just to test and be prepared for this scale. And we are not alone in this way, because I used to work for Amazon, for AWS, and you can imagine that you are not, and we are playing the same game because we are bigger and bigger, Nebius as a provider. You are not able to test big scale infrastructure because you have to create infrastructure the same size as the production. And next you need to create a load similar to the real load, which is not possible, right? And that is why there is no simple way to get rid of unknown unknowns. Of course, we are doing our best to, with E2E tests and so on and so on. But at the same time, we know that we will fail. If I say, oh, no, we never fail, don't trust me. Of course we fail. Of course we fail, and of course we see these problems for the whole industry that, unfortunately, GPU infrastructure, InfiniBand infrastructure, is so complicated. And we still fight with reliability versus performance and all the things. That is why we decided, okay, we will fail, no doubts. And we design our platform to fail, design for failure. And here we are focused not just only on reliability. Probably you know the common definition, one of the common definitions of availability via MTBF, MTTR. Mean time between failure, so it's better if you fail more rare, not often. And MTTR is mean time to recover, when you recover faster. And simple math, I decided, I promise you not to give you too much technical details, but the formula is very, very simple, and if you check it, you will see that MTTR is more sensitive parameter. So it's better to invest to let's say, 20% improving recovery time is better than 20% improving your mean time between failures. And it is about not just reliability, but also resilience, because reliable system is, staying strong, but resilient system is staying strong against, all the problems that are always trying to fail, or to break it, with failed components and so on and so on. So we are very focused also on making our system resilient and improving our MTTR. Sorry, a little bit more technical things. When we are talking about MTTR, time to recover, it consists of two obvious things. Mean time to detect the problem, and next, recover, right? The whole recovery, you understand something bad happens, and next you start recovering, and you got the final good state, right? That is why, to improve our resiliency, our mean time to recover, first of all, we have to health check. And we are very, very aggressively health checking our components and different, pieces of the platform. And next, to reduce our recovery time, we have to make the best to auto-heal the system, right? Instead of making a root cause analysis, what happened, instead of making the decision, okay, we need to recover something, system has to, self-heal itself. And it has to self-heal itself safe way. Because if you just take out the component, if you drain a component and swap with a healthy node, for example, of course you can potentially break the already existing training model, and you have to recover from the checkpoint, and all of you, all these problems. That is why our self-healing has to be based on predictive maintenance. So we are trying to do our best to predict this component probably is not really reliable. And we are waiting for the right time to get rid of this component and swap it with a healthy component when it will not influence hard on the training performance, and we don't need to recover from the checkpoint and so on and so on. So another thing, expectations. Model builders prefer and can take care about all the aspects of the top layers of the ML solution. So what does it mean? It means we are the GPU cloud provider, and we provide our infrastructure, and next, frameworks, all the things, it's up to the customer. They are smarter than us. They understand how to deal with that. What is the reality? Again, our customers, they say again and again, we see the same story. Guys, we'd like to be focused on interesting things. We'd like to be focused on our business. We'd like to be focused on R&D and the value we bring to our investors, to our end users. We don't like to care about how to configure monitoring of the top level of our training jobs and so on and so on. We don't like to be focused on root cause analysis of the problems, how to fix them, and so on and so on. And in this perspective, of course, we also have to deliver a solution, right? And the solution is, the first one is to help automate the top layer of management as well. So it is probably, you are familiar with the shared responsibility model with a general cloud providers, right? So according to the general responsibility model, shared responsibility model, so provider is responsible for reliability and security of the cloud, and it's a customer responsibilities to take care about security, reliability, performance in the cloud. Here we are trying to play the game where we are doing our best to help our customers to care about what happens on the top levels in the top level area, let's say. And we are developing the things those help to automate management, including prolog, epilog, job checks. So we are trying to do some alerting, auto-healing, and so on, also on the top levels. As well as we do understand that it's not, so we are playing the game. It's an interesting game because when we are talking about general cloud, in many cases, so what is needed to the customer? So they need database, they need computing, they need network. So it's a kind of, the standard set of building blocks, right? And probably most of the customers, they have an expertise here, and they know how to create it. I don't know, load balancer, some number of virtual machines, and so on and so on. What we see in this new market, almost every customer is unique. Some teams, they are very, very good in, let's say, platform or GPU cloud area. They are very familiar with Kubernetes, with Slurm, and so on. Some guys, they say, no, we are ML guys. We don't care about all the things. And that is why what we see when we are talking about large-scale model trainings, large-scale projects in general, we have to be able to help with that specific problems. And again, so in perspective of my department, customer experience department, I have to be ready for such requests. In case if the customer needs some help with creating RAG, developing RAG, or fine-tuning their model, or helping them with Kubernetes because they just don't have resources to do this stuff. So we are doing our best on all the levels of this, let's say, training areas, from the infrastructure to the top level, and even troubleshooting some problems on the level of specific frameworks, ML frameworks. Last but not least, never trust anyone. Kind of provocative, right? So if I say, guys, we deliver the best in the world clouds, so we are best in large-scale GPU training, blah blah blah. Of course, Vasily, what is the proof? How you can prove that your platform is really good? That truth is, you shouldn't trust me. In all the cases, in 100% of the cases, when we are talking about large-scale training, we start with POC, proof of concept, pilot project, all of the cases. And we do deliver and we do invest a lot of resources to make these projects smooth. Just for example, one of the recent POCs delivered by my team, it was more than 4,000 GPU POC, not production, POC, for a period of time longer than 1 week. You can imagine how it costs, and we invested there. And we invested time of our developers to make some adjustments. We also, the team of solution architect, supported with creating the cluster. And it, of course, we're happy to support with POC, not just from 4K, but even smaller. You need to assemble the cluster. We assemble the cluster. We test the cluster. We get rid of failed component. We reassemble the cluster and re-execute all the things. We prepare all the necessary things for the customer, like a Slurm and a separator, which was shared in the previous session. And next, we go with the customer, trying to understand what are the pain points. Okay, Mr. Customer, what do you think if performance of your storage is enough? No? Okay, let's tune some performance. Let's go with other alternative solutions, and so on and so on. So that is why my suggestion to you, if you have large-scale workloads, if you are thinking in terms of big models, please let us know. Probably we have some stuff to discuss. Thank you very much.
So, as usual, questions? Please. Just 1 second, microphone is coming to you.
Hey, thank you for the lecture. I would like to ask, What's the Nebius offer to customers who want to run a slightly adjacent workflows to large-scale model training, like, for example, synthetic data generation at scale using RTX GPUs?
Sorry, could you please rephrase your question?
Yeah,
answer a little bit louder because.
Oh yeah, sure.
Yeah.
So synthetic data generation at scale using RTX GPUs. What's the Nebius offer regarding that?
Let me maybe try to
thank
answer. I think you use RTX because you need video generation capabilities. Yes, that's right?
Yeah, that's right. Like rendering, classical rendering workflows using any kind of 3D software. Usually that's done through rendering farms, but in the context of large-scale model trainings, sometimes those are pretty adjacent, and that's basically about data set generations.
Okay, got it. Yes. So basically, we like, as you know, like H100, H200s do not support this like graphical mode. For that, we offer L40S GPUs that are connected. They're not connected in InfiniBand, and they're just connected to our usual compute servers. You can get, I think, up to 4 GPUs per virtual machine for them and use this. So, and we will continue supporting this like PCIe, like GPUs with graphical mode, basically. Thank you. Any other questions? Please, there is. Here, yes. Please keep your hand. Thank you.
Thank you. Maybe I have a suggestion.
Could you please louder?
Yeah,
or
I have a suggestion. Thank you for your good speech. You are a good storyteller, actually. It's a quite hard journey. My suggestion is to have a parallel workforce, thinking workforce, that logging every details that we already do. I'm speaking about how we can build such systems, which is a very complex systems. So if we have a complete log of that record, of that story, I think NVIDIA used to manage how to implement that kind of solving problems, automated solving problems. With that log, we can feed that log to AI models that can visualize or virtualize what is possible on these complex systems and then provide the maximum possible solutions.
Yeah, so observability is one of our priorities, and actually it's interesting that Narek is here because observability product team is
more interesting case. Let me just help.
Okay.
Yes, help you. So like basically we're NVIDIA, maybe I'm not allowed to say that, yes, but
what I will say.
NVIDIA is developing such systems which help to find like failures from the logs, from everything using AI, basically. And like actually like we partner with NVIDIA to be like first adopters of such systems. So it's a good that you have this suggestion, and we are moving.
Yeah,
So in 2 weeks' time, we have GPU Technology Conference in the United States. Do join that.
In 3 weeks.
3 weeks, yes.
Yeah.
Like that.
Okay. Good luck, yes, very complex.
But
yes.
in general, yeah, so you're totally right. So we do believe that sharing is better than hiding
Maybe,
information.
no.
So if we can, and if NVIDIA allows us to share logs,
my idea is pulling ourselves out as humans from the decision. We keep making those decisions. How about we made a system, an AI system that can decide?
A lot of that is already there. Like we have 4,000 GPUs running. Something crashes. The last thing you want is for an administrator to SSH in for 20 minutes.
Even the design, on the design layer. How can we design or have the optimal design for the whole system, for the management as well, and for the customer support as well? Or what do sometimes I feel that the market need to scale up and looking for these details, because sometimes a model can solve such problems, like taking out the output of this technology and use it to solve those problems. This is what I'm thinking.
Yeah,
Thank
you. Thank you for the feedback.
Thank you. So, thank you, Vasily.
Yeah, thank you very much.
Continue.